NASA hit the jackpot this week. The holy grail of planetary research is to find flowing liquid water which can one day perhaps sustain life.
Today marks the end of an era and the beginning of a new one.
In a jaw-dropping revelation that could reshape our understanding of the universe, physicist Michio Kaku has unveiled something terrifying that could forever change the course of human history.
We're changing the Earth. We can also change Mars, of course, over a period of many decades.
Recent findings suggest that Mars was only sometimes the desolate, cold world we imagine it to be. It might have once been a thriving planet, teeming with life and potential. This shocking announcement comes after years of meticulous research and exploration by NASA's Curiosity, InSight, and Perseverance rovers. What did these rovers discover? Join us as we delve into what Michio Kaku just announced about NASA's terrifying discovery on Mars.
There is life on Mars.
The discovery of water.
This week, NASA confirmed the existence of flowing liquid salt water on the red planet.
Water, though it seems common on our blue planet, is not a guaranteed element in the vast expanses of space. The discovery of water on Mars was a big surprise. It pushed the boundaries of what we know about the planet's past and its potential to support life. Scientists used advanced imaging techniques and rovers like the Mars Reconnaissance Orbiter, Curiosity, and Perseverance to find evidence of liquid water in the past and lots of water ice on Mars today. They first found clues in specific minerals like hematite and gypsum, which usually form in water on Earth. In recent years, new tools like the Mars Advanced Radar for subsurface and ionosphere sounding, MARSIS, aboard the Mars Express spacecraft, have given more direct evidence. They discovered huge amounts of underground water ice and even a subglacial lake similar to those under Earth's polar ice caps. All these discoveries got people like Michio Kaku excited. It shows us that space exploration is always changing and getting more complicated. Finding water on Mars gives us hope that maybe, just maybe, there's life out there somewhere beyond our home planet. But there's still so much we don't know about Mars and the rest of our solar system. Each discovery is like a stepping stone, helping us figure out where to go next in our journey through space. And who knows, maybe one day we'll even live on Mars. But before we can do that, we need to learn as much as we can about the red planet. So, every little bit of information we gather helps light the way for future explorers. We're like pioneers, blazing a trail through the cosmos, one discovery at a time. And who knows what we'll find out there beyond the stars. Geological makeup of Mars. Understanding the accomplishments of NASA's InSight mission on Mars is much easier when we look back at how scientists solved the mystery of Earth's core over 100 years ago. They did this by studying seismic waves, which are shock waves that travel through the Earth's depths. These waves can come from natural events like earthquakes, or from man-made explosions. Scientists analyze how seismic waves move through different materials to learn about those materials. It's similar to how light waves behave when they interact with objects. They can be transmitted, reflected, absorbed, refracted, polarized, diffracted, or scattered. Seismic waves change their behavior based on the substances they encounter. There are two main types of seismic waves, P waves and S waves. P waves, also known as primary waves, are compressional waves that make rocks vibrate in the same direction as the wave. They are the fastest seismic waves and are the first to arrive after an earthquake. S waves, or secondary waves, are shear waves that make rocks vibrate perpendicular to the wave's direction. They travel at about 60% of the speed of P waves and usually arrive after P waves. In 1806, seismologists discovered something important. Seismic waves travel slower through the Earth's core than through other parts of the planet. This revelation was crucial in understanding the composition and behavior of Earth's core. Moreover, scientists observed an interesting phenomenon. S waves could not pass through the core, while P waves could, but they bent when they reached the core's boundary. From these observations, scientists concluded that the outer core is liquid, while the solid mantle surrounds it. Further studies in 1936 showed seismic waves bouncing off the inner core, indicating a change from liquid to solid. These discoveries, made through careful seismic studies, greatly improved our understanding of the Earth's core. Now, let's fast forward almost a century to the exploration of Mars' interior. In 2018, NASA's Mars InSight lander began a mission to study Mars' crust, mantle, and core, using seismic investigations, geodesy, and heat transport. A crucial part of this mission was deploying a seismometer called the Seismic Experiment for Interior Structure, CIS, on the Martian surface. This instrument was designed to measure seismic activity and create detailed 3D models of Mars' interior. During its 4-year mission, InSight made a significant discovery on Mars in 2021. 2 major events occurred on the opposite side of the planet, which caught scientists' attention. Firstly, InSight recorded a massive Marsquake, the largest seismic activity ever detected on Mars. Secondly, a meteorite impact caused a seismic disturbance. These events happened far from InSight's location, offering a unique opportunity to study seismic waves traveling through Mars. This provided researchers with an unprecedented view into the Martian core. As scientists compared the travel times of seismic waves through Mars' core with those in the Martian mantle, they found something intriguing. By combining this data with other seismic and geophysical measurements, researchers could estimate the density and compressibility of the materials the waves encountered. Surprisingly, their findings showed that Mars's core is entirely liquid, unlike Earth's core, which likely has a solid inner part surrounded by a liquid outer core, possibly with an even denser innermost core. Further investigations revealed that Mars's core contains a significant amount of lighter elements mixed in. On average, these elements make up nearly a fifth of the planet's weight, with sulfur being the most common, along with smaller amounts of oxygen, carbon, and hydrogen. This unexpected composition sheds light on the unique geological characteristics of Mars. These discoveries suggest that Mars's core is less dense and more compressible compared to Earth's. On Earth, the geodynamo activity within the core is what sustains the magnetic field. In simpler terms, heat from the inner core flows to the outer core, creating currents in the conductive fluid within the mantle. As the planet rotates, these currents twist, generating a magnetic field. This magnetic field then interacts with the fluid motion, creating a secondary magnetic field known as the dynamo effect. This mechanism is what maintains Earth's magnetic field over time. Previous studies suggested that the presence of lighter elements in Mars's core might have caused its dynamo to weaken, leading to the loss of its magnetic field. With a better understanding of the composition of Mars's core, scientists can now piece together the planet's history more accurately. The characteristics of a planet's core provide important clues about how it formed and evolved. Earth has a unique core composition that allows it to generate a magnetic field. This magnetic field acts as a shield, protecting our planet from solar winds. This shield helps preserve Earth's water and creates a suitable environment for life to thrive. In contrast, Mars's core cannot generate this protective shield, making it inhospitable to known life forms. Studying Mars's core not only helps identify potentially habitable exoplanets, but also enhances our understanding of how planets can form, grow, and change over time. Even planets made of similar materials and orbiting the same star can evolve differently. The InSight mission, which ended in December 2022, greatly improved our understanding of planetary formation and evolution. The mission collected high-quality data during its 4-year exploration of Mars. It serves as a reminder of the importance of scientific exploration and discovery. Existence of methane. Methane, a simple organic molecule, has piqued the interest of scientists because it could indicate the possibility of past life on Mars. In recent years, a fascinating mystery has unfolded regarding the presence of methane in the Martian atmosphere. Methane is important because on Earth, most of the methane in our atmosphere comes from living organisms. NASA's Curiosity rover, a key tool in exploring Mars, detected significant spikes in methane levels in Mars's atmosphere that changed with the seasons. The Mars Science Laboratory, which housed the Curiosity rover, had advanced instruments capable of detailed chemical analyses, including measuring methane levels. Using this technology, scientists found that methane levels on Mars ranged from 0.24 to 0.65 parts per billion, peaking during the Martian summer. Several theories have been proposed to explain the source of methane on Mars. It could be produced by geological processes, such as serpentinization, where water reacts with certain minerals, releasing methane. Alternatively, methane could come from ancient methane trapped in Martian ice cages called clathrates, which are released periodically due to temperature changes. Another intriguing possibility is that the methane could be biological, produced by microorganisms, similar to how methane is produced on Earth. Understanding the source of methane on Mars is crucial for determining if the planet could have supported life in the past. If methane is being produced currently, it could indicate the presence of microbial life on Mars. However, methane can also be produced by non-biological processes, so further research is needed to confirm its source. Detection of over 1,300 seismic events.
We're changing the Earth. We can also change Mars, of course, over a period of many decades.
The InSight mission not only provided groundbreaking insights into Mars's core, but also uncovered several other fascinating discoveries about the planet. It detected more than seismic events, with over 50 of them showing clear signals that allowed for precise location determination. The region known as Cerberus Fossae, which shows evidence of recent volcanic activity, emerged as the largest cluster of high-quality seismic events. These findings suggest that Mars has experienced periods of geological activity within the past 2 million years. One of the most significant seismic events occurred in mid-2021, with InSight detecting all 6 of the largest events since then. The most recent event in May 2022 had an estimated magnitude of 5, causing reverberations throughout the planet for at least 6 hours. This highlights the dynamic nature of Mars's interior. In addition, InSight's findings shed light on Mars's major layers, including the crust, mantle, and core. Surprisingly, the crust beneath InSight was found to be thinner than expected, measuring approximately 15 to 25 miles in thickness and consisting of 3 internal layers. The top layer of the crust is around 6.2 miles thick and less dense compared to the lower crust. Another unexpected discovery was that Mars's core is significantly larger than previously thought, with a radius of about 1,120 miles. The lower density of the core suggests the presence of lighter elements mixed with molten iron. This explains why the core remains in a molten state, despite cooling over time. These findings were made possible through the analysis of seismic waves traveling from the upper mantle to the surface of Mars. They provide valuable insights into the planet's geological history and its potential for supporting life. The InSight mission has significantly advanced our understanding of Mars and its complex interior. The InSight mission has made remarkable discoveries about Mars, revealing the presence of a thick, cold outer shell called the lithosphere, which is about 310 miles thick. This lithosphere sets Mars apart from Earth, as it sits above a relatively cooler mantle. Understanding the composition, structure, and heat escape rates of Mars's different layers has given us valuable insights into the planet's geological history and its potential to support life. InSight's findings have significantly enhanced our understanding of Mars's surface conditions and its evolution as a potentially habitable planet. Besides exploring Mars's interior, the mission has collected important atmospheric and weather data. By using its comprehensive weather sensors, the spacecraft has detected thousands of passing dust devils. While direct images of these dust devils were not captured by the mission's cameras, InSight's pressure sensor recorded the pressure dips caused by these whirlwinds. Additionally, the seismometer detected surface tilts induced by the dust devils, resembling the effect of a huge vacuum cleaner pulling on the surface. In addition to dust devils, InSight has observed other atmospheric phenomena on Mars, such as weather fronts, dust storms, turbulence, infrasound, and Bohr waves. These observations have given us a thorough understanding of Mars's dynamic weather patterns and atmospheric processes. This knowledge is crucial for future missions and potential human exploration of the planet. Notably, InSight carried the first ever magnetometer instrument to the Martian surface, allowing the detection of magnetic signals. Ancient rocks found between depths of 200 feet and several miles below the surface showed magnetic properties 10 times stronger than expected, based on measurements from orbiting spacecraft. Scientists have also identified variations in magnetic signals between day and night, with noticeable pulsations around midnight. These findings provide potential insights into the interaction between the solar wind and Mars's atmosphere. Martian weather pattern. The weather on Mars is much more varied and complex than we used to think. thanks to NASA's rovers and orbiters. While Mars is often seen as a static red desert, it experiences diverse weather patterns, including dust storms, frosts, and rapidly changing atmospheric conditions. NASA's Mars Atmospheric and Volatile Evolution Methane mission has provided details about how the Martian climate changes with the seasons. Instruments on the Mars Reconnaissance Orbiter, MRO, and the Mars Climate Sounder have also given us key insights into daily and seasonal weather patterns on Mars. Mars experiences weather phenomena similar to Earth, such as the growth and retreat of polar ice caps made from carbon dioxide. Additionally, it has the largest dust storms in the solar system, which can cover the entire planet and last for months. NASA's rovers have found evidence of frost and snow on Mars as well. The Curiosity rover's Environmental Monitoring Station, REMS, detected humidity and ground frost at the Gale crater. Further investigations have revealed that Mars has whirlwinds known as dust devils, which are much larger and more common than their earthly counterparts. Mars also undergoes significant temperature fluctuations, with temperatures ranging from a high of 20 degrees Celsius during the day to a frigid minus 73 degrees Celsius at night. Studying Martian weather patterns not only helps us understand the planet's geological history, but also provides crucial information for future manned missions to Mars. Accurate predictions of weather patterns will be essential for choosing landing sites, maintaining equipment, and ensuring the safety of astronauts. The study of Martian weather has shown us that Mars is not a static, unchanging world, but a dynamic and diverse planet. Martian night glow. Michio Kaku often delves into the mysterious aspects of Mars.
It will take centuries to terraform Mars. Mars is a gigantic planet,
Such as its intriguing night glow. This faint luminosity in the Martian atmosphere, visible even without direct sunlight, was confirmed by NASA's Methane spacecraft. The glow occurs due to chemical reactions high in Mars's atmosphere. During the day, solar radiation breaks down carbon dioxide into carbon monoxide and oxygen. At night, these atoms recombine to form carbon dioxide again, releasing energy as visible light and creating a glow. The Martian night glow isn't constant. It varies with the seasons, peaking at the equinoxes and decreasing at the solstices. It also pulsates about 3 times each night. These fluctuations provide scientists with insights into the atmospheric circulation patterns on Mars, showing how winds move at high altitudes and change with the seasons. Studying Mars's night glow is crucial for understanding the planet's atmospheric dynamics, including the movement of winds at upper levels and how these patterns change across Martian seasons. These findings deepen our understanding of Mars's climate history and current conditions. They also highlight Mars's dynamic nature, with complex atmospheric and geological activities. Discovery of organic molecules. Michio Kaku highlighted a major discovery about Mars, the identification of organic molecules on the planet, a significant advancement in the search for signs of life. Organic molecules are crucial carbon-based compounds for life as we know it. Finding them on Mars suggests that the planet might have had the basic building blocks necessary for life. NASA's Curiosity rover made this discovery during its exploration of the Gale crater, where it found a variety of organic molecules in the ancient lake bed. This was possible through its sample analysis at Mars, SAM's suite of instruments, which can heat soil and rock samples to release and identify organic molecules. Among the molecules detected were benzene and propane, simple organic compounds that could be linked to more complex molecules. This discovery opens up new possibilities and adds a fascinating layer to our understanding of Mars and its potential for supporting life. Finding organic matter in Gale crater is significant because this region is believed to have once hosted a lake billions of years ago. The discovery of these molecules within mudstone, a sedimentary rock formed from mud at the bottom of water bodies, raises the intriguing possibility that life might have thrived during the lake's existence. However, it's important to note that the presence of organic molecules does not conclusively indicate past life on Mars. These molecules could also come from geological processes or be delivered to Mars through meteorites. Nonetheless, their existence provides an encouraging hint towards the potential for past life on Mars. Martian unusual geology. Through the eyes of orbiters, landers, and rovers, we have started to uncover the fascinating geology of Mars in incredible detail. Michio Kaku often highlights the unique geological features of Mars, which provide clues about the planet's past and the conditions that may have existed there. One of the most striking aspects of Martian geology is its massive volcanoes. Olympus Mons, a shield volcano, is the largest volcano in the solar system, towering at 13.6 miles high, nearly 3 times the height of Mount Everest. This enormous size is due to the lack of tectonic plate activity on Mars, allowing lava to flow and accumulate in one location over billions of years. Another remarkable feature is the vast canyon system of Valles Marineris, stretching over 2,500 miles long and up to 4.35 miles deep, dwarfing Earth's Grand Canyon. This colossal geological feature may have formed due to the cracking and collapsing of the Martian crust. In terms of minerals, Mars has also provided surprises. The discovery of a mineral called tridymite, typically associated with silicic volcanism, a type of volcanic activity common on Earth but not thought to occur on Mars, has challenged scientists' understanding of Mars's volcanic history. These unique geological features on Mars offer a glimpse into the planet's intriguing past and its geological processes, highlighting the dynamic nature of our neighboring planet. Signs of past lives. The search for life beyond Earth has long fascinated scientists, with Mars becoming a key focus due to its Earth-like history. NASA's missions to Mars have revealed intriguing clues that suggest the red planet may have had conditions suitable for life in the past. One significant discovery was made by the Mars rover Curiosity, which detected organic molecules in ancient sedimentary rocks that are around 3 billion years old. This finding is particularly compelling because organic molecules are essential for life as we know it. Additionally, Curiosity observed seasonal fluctuations in methane levels on Mars, a phenomenon that is intriguingly linked to biological activity on Earth. While the presence of organic molecules does not definitively prove past life on Mars, as they can also be produced by non-biological processes, it does suggest that the necessary ingredients for life were once present. The Perseverance rover is currently exploring the Jezero crater, believed to be an ancient lake, in search of more concrete evidence of ancient microbial life, such as biosignatures, which could further support the idea of Mars as a once habitable environment. Ice reservoirs. On Mars, Michio Kaku has emphasized the importance of finding ice deposits on Mars, a discovery that has profoundly changed our understanding of the planet's history and potential. Water, essential for life as we know it, plays a crucial role in this discovery. The presence of ice on Mars indicates that water, and possibly life, might have existed in the past, and could potentially support future human exploration. Mars boasts well-known and easily accessible reservoirs of water ice, particularly the polar ice caps, which are visible even through telescopes on Earth. The southern polar cap, for instance, contains a permanent water ice layer about 3 kilometers thick. The Mars Reconnaissance Orbiter, MRO, has revealed substantial subsurface ice deposits in the mid-latitudes through its Orbiter Shallow Radar, SHARAD. These deposits, consisting of ice, dust, and rock layers, may be reachable for future astronaut missions. Researchers have identified an ice reservoir comparable in size to Earth's largest Great Lake, Lake Superior. These subterranean ice deposits, shielded by layers of dust and rock, have remained well preserved for potentially millions of years due to Mars's thin atmosphere, which is remarkably pure with only around 10% mixed with dust. This ice holds promising qualities. Most recently, the Mars Advanced Radar for Subsurface and Ionosphere Sounding, MARSIS, on the Mars Express spacecraft, detected signs of a sizable saltwater lake beneath the ice at Mars's south pole. This discovery adds a new dimension to our understanding of water on Mars, suggesting that liquid water could still exist below the surface under specific conditions. The revelation of these ice reservoirs carries significant implications for Mars's potential habitability and upcoming human missions. The ice can serve various purposes, from providing drinking water and supporting agriculture to even being a resource for creating rocket fuel. Now it's time for today's subscriber pick. Michio Kaku just announced NASA's terrifying discovery on Mars. Interestingly, one of the discoveries is water, a vital ingredient for life. This is a milestone in our quest to understand the universe. Water is essential for life as we know it, and its presence on Mars has profound implications. While we often take water for granted on Earth, finding it on another planet is a remarkable discovery. Scientists have long believed that the presence of water is a key indicator of potential life on other celestial bodies. The search for water on Mars has been a journey of exploration that has deepened our understanding of the planet's history and its ability to support life. Modern imaging technologies and exploration rovers, such as the Mars Reconnaissance Orbiter, Curiosity, and Perseverance, have played pivotal roles in this discovery. These tools have revealed solid proof of liquid water in Mars's past and significant amounts of water ice on the planet today. Recent advancements in ground-penetrating radar, like the Mars Advanced Radar for Subsurface and Ionosphere Sounding, MARSIS on the Mars Express spacecraft, have provided even more direct evidence. Scientists have uncovered extensive underground water ice reservoirs and a subglacial lake resembling those found beneath Earth's polar ice caps. The discovery of water on Mars opens up new possibilities for future exploration and the search for life beyond Earth. It challenges us to rethink our place in the universe and our understanding of what it means to be alive. Here comes the intriguing question. Are you willing to migrate to Mars in the future? Let us know your thoughts in the comments below. Mars' ancient rivers and lakes. Michio Kaku often highlights the intriguing geological formations on Mars that suggest the planet once had rivers and lakes, providing strong evidence of a wetter climate in the past that could have been conducive to life. High-resolution images from Mars orbiters have revealed numerous channels, valleys, and deltas across the Martian surface, all indicating past water flow. One of the most compelling pieces of evidence is the network of ancient river valleys found on Mars. These dried-up systems resemble river networks on Earth, suggesting they were formed by sustained water flow over a long period. NASA's rovers have explored various locations believed to have been ancient lakes. For instance, Gale Crater, where the Curiosity rover landed, is thought to have once been filled with water, forming a lake about the size of Connecticut and Rhode Island combined. Curiosity has discovered rounded pebbles along its route, which geologists recognize as a sign of long-distance water transport. These pebbles suggest the existence of flowing water, likely from a small stream. The Perseverance rover is currently exploring Jezero Crater, believed to have been a lake about the size of Lake Tahoe on Earth. Jezero is particularly exciting because it contains a well-preserved river delta where sediments were deposited over time by water flowing into the lake, making it a prime location to search for signs of past life. The presence of ancient rivers and lakes on Mars indicates that the planet had a warmer, wetter past where life as we know it could have existed. While no definitive signs of life have been found so far, these bodies of water offer exciting areas to continue the search. Evidence of ancient tsunamis. Michio Kaku has brought attention to a fascinating discovery about Mars, the signs that suggest ancient tsunamis once swept across the planet. These findings hint that Mars might not have always been the dry, barren world we see today, but could have had a significant amount of water in the past. Researchers have identified geological formations in the northern plains of Mars that resemble the remnants of massive tsunamis. These formations indicate the occurrence of two distinct tsunami events, likely triggered by meteor impacts. These tsunamis would have been incredibly powerful, surging across the plains and leaving behind substantial boulders and debris in their wake. The tsunamis are estimated to have occurred around 3.4 billion years ago, during Mars's late Hesperian period, a time when the planet is believed to have been cold and icy. After the tsunamis retreated, they would have left behind deposits of ice. These tsunami deposits provide additional support for the idea of an ancient ocean in Mars's northern plains, a hypothesis that has sparked scientific discussions. If validated, this discovery would imply a significant presence of water on ancient Mars, potentially creating habitats conducive to life. The unveiling of these tsunami deposits also has implications for the exploration of past life on Mars. The areas where the tsunamis deposited water and sediment might be promising locations to search for signs of ancient life. These findings, along with others, continue to paint a picture of a Mars that was substantially different from the cold, arid environment we see today. The evidence of its watery history provides intriguing insights into Mars's potential to support life in its ancient past. The seasonal flow of Mars. The seasonal flows, known as recurring slope linii, RSL, on Mars, have fascinated scientists like Michio Kaku. These dark streaks appear on Mars's surface during warm temperatures, fade during the colder seasons, and then reappear annually. First observed by the Mars Reconnaissance Orbiter, the seasonal flows usually appear on steep slopes and crater walls. The streaks can extend hundreds of meters and are typically narrower than 5 meters. They start forming when Mars's surface temperature climbs above -23 degrees Celsius and disappear in colder weather, or when the sun doesn't shine on the slope. The exact mechanism causing these seasonal flows remains a mystery, and they have been the subject of numerous scientific hypotheses. Early theories suggested that they might be caused by the flow of briny water, potentially from melting subsurface ice or underground aquifers. More recent studies suggest that RSL might be the result of dry flows of sand and dust, driven by sunlight heating the surface. This would make the flows similar to certain types of landslides seen on Earth. Despite the uncertainty, the seasonal flows continue to be of interest because if they are caused by salty water, they might provide a habitat for hardy microorganisms. This possibility presents another opportunity in the search for life on Mars, and will undoubtedly continue to drive future investigations. Thanks for watching, and we'll see you in the next one.